Met a few of you about 9 years ago when I first came to New York in a TouchIn event at the old studio of Volvox. So thank you so much, Derivative, and thank you, Volvox, for bringing the community back together and giving me the opportunity to present here. My name is Georgios. My background is in computer animation and visual effects. But over the years, I've been working on a bunch of different personal projects, whether it's computer animation, real-time, but also a lot of programming. So today I'm going to talk about one project, which is actually the last project of a whole series of works I've been doing in data sonification. Back in 2016, with this project, which is a pre-rendered short animation, I did this in Houdini, and it started from the question, what does a digital object sound like? And essentially, I put together a very simple sonification technique where if we think about like high quality audio at 48 kilohertz requires 48,000 samples per second, right? So what I do in this process, I simply take the coordinates of all the points that make up an object, and I repurpose them as audio sample. So there's no really any audio synthesis. The data that describe the object really become audio, and this allows you to essentially listen exactly what you see and see what you listen, and vice versa. And over the years, I kind of like took this idea, and I've done a whole series of works in animation where I'm using geometric data, images, text, LiDAR scans, or even personal information to sort of like create these data sonifications. We don't have time to see any of those, but if you feel like, you can go to my website and they're all available there for you to see. But over the years, I was dreaming to go back to the initial idea of using geometries as the source input. But the dream was to essentially build an interactive application where in real time, I would be able to manipulate the geometries and essentially sculpt the sound visually, right? So earlier this year in February, so this is where GeoSynth comes in. In fact, back in February, I was an artist in residence at the Watermill Center in Long Island, where I spent 3 weeks there developing most of the application. And I'm calling this GeoSynth, and with it, later on, I built a performance, which I call Primitive Sounds, which was premiered at the Noasis Onyx studio a couple of months ago. So yeah, stay in touch. There's a good possibility I'll be doing this again, so stay in touch if you want to experience it in first person. So let's jump right into the application just to see what this does. So here I have a collection of 8 objects. The synthesizer has at the moment 8 tracks because I'm limited by my MIDI controller. And I have these primitives. I can also go in, where is it? Here. I can start. And I'm using Bitwig to, as I said, this is just an instrument, right? And part of the idea was to be able to use this as a standalone instrument that can connect with other devices or applications. So in this case, I'm using Bitwig, and I can trigger. I wish we had more time. I'll do the whole performance, but thank you. So I'm gonna try to show you some of the key components that I'm using, because I have to say, for this application, what is important is that both rendering and audio is happening at the same time. So the audio is actually all processed in the GPU, which allows me to run everything. And actually running in real time is very crucial, because the moment I start losing frames, the sound also goes out of whack. So I'm just going to take you through some of the key components. I'm going to start off by saying that, as I mentioned, this is an instrument, and knowing that I'll be using this in several projects, it was important for me to separate the engine from the scene, right? So how to build a framework where I could swap, change the objects and the layouts without having to re-engineer my setup. So these are the key components, but on the side, these are different scenes, right? So, and when I say scenes, let me actually reset this. When I talk about scenes, I really refer to a collection of objects that kind of make up my setup. So I mentioned that I'm using 8 different tracks. So each one of these lines represents an asset that ends up going to the engine, right? So, and I have a little framework here where I can take every asset. Let's say I'm going and over here, I have a bunch of components that will actually deform the geometry. Deformation, and then this is this one. And if I start from the the loader, you'll notice here that I'm loading the asset. One important aspect of this is being able to tune my objects, even though these are different objects, because I want to be able to play melodies that are in tune. I did this. So for instance, if I remove, essentially I have an auto-tune function. If I remove this, you'll notice that the sphere and the torus produce a different tone. But the way I'm doing this is the moment I bring the asset into Touch Designer, I I use an app on my phone to measure the the native frequency, which I plug here, and then I can reverse it when I auto-tune. So now the two objects, apart from the deformation, they play the same. They play the same note, which was kind of important. Other things that I'm specifying on the loader is the attack and the release. And then if we jump inside here, you'll see that every asset is a collection of different data. So for every asset, I have a SOP. I have 3 textures for the positions, the normalized position, which is what goes into for the audio, and then some UVs, which I'm using for special cases. But together with this, there is a SOP with all the information, how many points, the bounding box, and the octave the asset needs to play at. But the problem I came across is how do I pipe all this information through my this framework? And I tried a few different ways. And where I end up, which I think works pretty well, instead of piping the assets from one component to the other, essentially I'm passing a DAT which contains pointers to the data that I'm interested to grab on the other places. So here you see all the pointers and all the different components. So every modifier, every component I have after that the moment I modify the texture, apart from modifying the texture, which is sort of like it's happening here with GLSL, I'm also making sure that I'm swapping the address of that component. So you'll notice here the dot, if I connect it, this is sort of like the initial pointers, the initial references, and then I keep replacing them every time I modify. So for instance, if I turn this on and off, this replaces. So the rest of the system kind of pulls the dot, and then from the dot, you can pull any information you're interested. And that makes it very convenient because I can put a switch node and I can instantly change my asset without having to jungle, kind of like manage all the different aspects of it. So this is the sort of like the scene aspect. And then from there, I'm going into sort of like the, somewhat like the audio engine, which, as I mentioned, it's happening, everything's happening in the GPU just for efficiency. And starting with the tracks, this is sort of like what is responsible for every asset. So if I go to, let's say, my Taurus, the first thing I do is load the asset, and from within there, you'll notice that I pull the dot, and from the dot, I can pull all the information I'm interested, the textures and the information. So I found that that was like the most efficient way to go about it. And then every track, I forgot to mention, every track can support up to 8 nodes that can run in parallel, so I can do polyphony. And you will notice here, this is like one of the nodes. The moment I trigger it, you'll see all these things are moving in parallel. So what's happening here, this is the texture which holds all the positions that, let's say, in this instance, it has 130,000 points. And the node will actually take that sample and basically do a slice. So based on the frequency that I want to play the node, if you see here, as I'm playing this node, you'll notice that the step, if you notice how the step changes, so the frequency defines basically how many steps I need to move forward, and then this will increment both the head and the tail of that slice as it's moving through my, let's say, wave, right? And then, inside the node, if I jump inside here, again, I'm pulling the data that I'm for the specific asset. And really, everything is happening on this GLSL shader, where, again, I'm pulling the head and the tail. And from this texture, I'm sort of like slicing. I'm taking, from the 100,000 pixels, I'm sort of like only extracting 800 pixels, which correspond to the time slice for that particular frame. And you'll notice I'm sampling 2 of them. In fact, this is the current frame, and this is the previous frame, because this is important. As you modify the wave, you kind of want to interpolate between the two so you don't get tearing. So these are, to be honest, I don't have a strong background in sound engineer, so this project kind of like made me learn a lot about signal processing and audio and all that, which has been very fascinating. So the next component, once I have now my sound representation is now in like a series of pixels, I can come back and add all the nodes together. So now here they like combine the 8 parallel nodes that may be playing together all at once. And the next step is sort of like how to mix those. So initially I was adding them all together and then moving the data from top to chop, and then running like a compressor. But I found that doing that way, sometimes the audio was getting muffled. So I got into like another rabbit hole where I end up doing my own compressor in GLSL, so I can compress the tracks individually before I mix them. So instead of adding them together, where I end up with like one line, I stack all the tracks on top of each other. So now here I have 8 pixels in height, and you can see how they kind of like light up. And then I go to my next component where inside here, I have a compute shader that does a number of things. So if I show you here, if I actually disable first this feature just to see what I'm doing. So because this object can be fairly arbitrary, the signal is almost never zero-centered, which is really bad for like audio. So you see here how the signal jumps way off the center. So the first thing I'm doing is sort of like by tracking a moving average, I can center it, sort of like reversing that, and then I can also compress it. So this is happening on every track individually in the GLSL. And also in this phase, I'm also doing the mapping stage. Because if you think about it, in coordinates, we have 3 dimensions, X, Y, and Z. So somewhere inside here, I'm taking the decision of how I'm going to map the 3 coordinates into 2 channels, left and right. So after I do this, then I'm ready to basically add all the tracks together, and then output them on the audio card, which again I run through like a compression to make sure nothing clips. And then similarly, that's how the rendering works, where I sort of like bring everything, all my assets in here, and I'm pulling the required data to sort of like render them with like custom shaders that will also deform the geometry. Before I wrap up, just to like, I'm going to show you like one last little feature that sort of like I was kind of proud to put together. In the performance, I want to have like a dynamic camera, and which is kind of like hard. You now kind of like moving the mouse by myself, but I end up putting together this module that sort of like will, with like some basic machine computer vision, essentially will look, if I show you here, I have these 2 bounding boxes. Essentially, I'm going to always have my objects within frame. So the blue is the ideal framing, but I have this component in here that, with a compute shader again, I'm sort of like detecting where's the first pixel and where's the last. And in fact, I'm doing this not on the render itself, but I have a secondary render to output only the objects I'm interested in. So in this case, the grid doesn't affect that feature. So going back in here, I can analyze the pixels and see essentially where is the first and the last scan line of my image. And then I consolidate all these values, and I can get the bounding box. And then from there, I can take these values, and through an extension, essentially drive the camera view to show like, where is it? Here, yeah, there you go. So as I move the object, the camera will auto-correct, so my object is always in place. And this is happening because even though Touch Designer can focus on objects, the moment you start deforming the objects on the GPU, that information is no longer in the CPU. So the way I managed to do that was by analyzing the pixel themselves. I think I'm going to end it here. Thank you so much.
Give it up.